Students, today we will learn the chapters Applications of Derivatives. As you already learned so many applications, now in this part I will explain you the increasing and decreasing function. As student, you come to know about this word increasing and decreasing. So I am going to be explaining you this, and the use of derivatives I will be explaining. Okay, so now you can see if we have this y-axis and x-axis. Now if there is a point x1 and x2 where x1 less than x2, and for x1 in any functions, when you put here fx1 and put here fx2, and you see that this one is fx1 and this one is fx2. What happened when we seeing this curve? This fx1 is less than this fx2, and it may be this way, that x1 less than x2, and it may be seen that fx1 greater than fx2. Then you can see, let this way, this one is fx1 and this one is x2. The graph may be this way. So you are seeing here fx1 is greater than fx2. Here fx1 is less than fx2. Okay, so here you are seeing fx1 less than fx2, and here you are seeing fx1 greater than fx2. So these two type of the graph you can find when you putting the value of x1 and x2. And also we can say when these functions is for all x1 and x2, if we put any value of x1 and x2 here and we find this type of the graph, you can see this one is increasing graph. Okay, and here you can see this one is decreasing graph. Okay, so we can say this condition is for increasing and this condition is for decreasing, right? So it is very easy to see what is the increasing and what is the decreasing in the graph, right? So now if putting the value of x1 and x2 in any functions and we calculate this, then this is a very tough job. For examples, I am telling you examples x square and x belongs to R. Now we can see x1 less than x2, so we can say x square less than x2 square, so we can say fx1 less than fx2. So what we can say about this graph without drawing? We can say it will be increasing. Okay, and here we can say, let here is a graph 1 upon x square and x1 less than x2, x1 square less than x2 square, and 1 upon x1 square greater than 1 upon x2 square. Student, you understand this one, isn't it? If it is 4, then it is 1 by 4, it is 5, then it is 1 by 5. So naturally this will be, sign will be changed. Okay, so we can say fx1 will be greater than fx2, hence function is decreasing function, right? So this one is the calculation method, but sometimes this calculation method is very tough, so we will use some other thing, that is, now you can say here is a graph at this point, x1, x2, x1 less than x2, and we let it is fx function. If we find f dash x and we find f dash x1, f dash means differential of the function, and we can say it is the slope of tangent. Okay, so it is slope of tangent. So we can think here that slope of tangent is acute angle. Here theta is acute, hence tan theta is greater than 0. Similarly, for this point also we can see here is again theta, where theta f dash x2 is greater than, is also less than f dash x2 equal to tan theta, then here also theta is acute, therefore tan theta is greater than 0, means positive. Okay, so if we can say if x1 less than x2, f dash x1 and f dash x2 is positive to positive, so we can say here is a increasing function. Okay, and similarly if we can see here, now you can see this one, this theta is obtuse, so tan theta is less than 0. Okay, so we can say f dash x1 and f dash x2 is negative, means f dash x less than 0, so we can say it is decreasing. Okay, so this way you can understand that by using calculation method and by using first derivative method, we can find the function is decreasing or increasing. But student, now I will also want to be explain it that if here is a function, that this one is function and this one and this one, now you can see it is increasing, but sometimes it may be increasing, it may be equal also. Okay, so we can say here it is only increasing function. But now in this graph, for all values of x, then we can say it is strictly, there is no any value where it will be equal, so we can say it is strictly increasing function. Strictly increasing. Okay, and similarly we can say for this type of the curve, and here is decreasing function. But now if explaining with this way, then we can say strictly decreasing. Meaning of increasing function we can say only if any time this will be equal, okay, and here is fx1 always less than fx2, okay, here fx1 always greater than fx2, but sometime it may be equal, okay. So this two curves I can say increasing and decreasing, and strictly increasing and strictly decreasing. Now what about this curve? This curve sometime increasing, sometime decreasing, and sometime again increasing. So we can say for this curve is neither increasing nor decreasing. Okay, we cannot say this function is not increasing always or always decreasing, but for a particular limit, if we take this limit only, then it is increasing. If we take this limit only, then it is decreasing. Okay, if limit is not given, interval is not given, then this graph is neither increasing nor decreasing. Later on I will be explaining this curve more. Okay, now I will like to tell you one theorem what we have learned here according to this. Condition number 1, x1 less than x2 in interval I, then fx1 less than equal than fx2. What is this tells? This tells increasing function. Okay, and now if x1 less than x2 in interval, and we can say fx1 greater than equal than fx2, then it is decreasing function. Okay, now third point is x1 less than x2 in interval I, and fx1 less than fx2, then it is strictly increasing. Okay, and x1 less than x2 in interval I, then we can say fx1 greater than fx2, then it is strictly decreasing. Okay, now similarly for we can check for first derivative test what we have learned. We can say this, it is if x1 f is increasing in closed interval a to b if f dash x greater than equal than 0 for each x belongs to a to b. Okay, now this is derivative. Greater than equal than 0 means positive. Okay, now f is strictly increasing in a to b if f dash x greater than 0 for each x belongs to a to b, and similarly f is decreasing in interval a to b if f dash x less than equal than 0 means negative for each x belongs to a to b, and similarly f is strictly decreasing if a to b f dash x less than 0 for x belongs to a to b. Okay, student. Now, using quadratic equations perfect squaring method, also we can find increasing values and decreasing values, right? We can understand this. So I am going to tell you some questions for this. Show that the function f given by fx equal to x cube minus 3x square plus 4x x belongs to R is strictly increasing on domain R. Now you can see fx equal to x cube minus 3x square plus 4x. Okay, now we can find f dash x, that is 3x square minus 6x plus 4, and now we can write this 3x square minus 2x plus 4. Now we can see here a square minus 2 into a into b. Okay, plus b square, so we have to subtract it. Now this is a perfect square plus 4. We can write 3x minus 1 whole square minus 1 plus 4. Open this bracket, we can write 3x minus 1 square minus 3 plus 4. Now we can write this 3x minus 1 whole square plus 1. And now we can say this is a perfect square. so it is always positive. If we put any value of x here, if it is 0 or greater than 0, so this adding with this is always positive. Okay, so we can say it is greater than 0 in every interval of R. Therefore, it is always greater than 0. So this phenomena f dash x greater than 0 tells it is the strictly increasing on R. Okay, therefore the function what I have described, are you understanding? F is strictly increasing on R. Are you understanding? For all values, never it is equal. It is always greater than 0. So it is strictly increasing. Now we can take one more question for this. So you will be understand this. Prove that the function given by fx equal to cos x is strictly decreasing in interval 0 to pi and strictly increasing in interval pi to 2 pi Now, third we can take neither increasing nor decreasing in interval 0 to 2 pi. Now, we will going to check it. Now, the question is given fx equal to cos x. So, we can say f dash x equal to minus sin x. Now, I will check about sin x. Since x belongs to 0 to pi, so sin x greater than 0 in interval. Okay, we know that in 0 to pi, first coordinate and second coordinate, value of sin x is positive. Right? This understand? From 0 to pi, sin x is positive. So now this is positive. Positive into minus means negative. Right? Hence, putting this value here, positive into minus. Hence, f dash x in our question is less than 0. So, f is strictly decreasing. Hence, f is strictly decreasing in 0 to pi. You can understand we are not taking the value of 0 and value of pi here. Okay, so it is positive. Positive into negative is negative. So f dash x is less than 0. Okay. Now similarly for second condition, since x belongs to pi to 2 pi, and we can understand the third and fourth coordinate sin x is less than 0. Now it is negative. Negative into negative is positive. Hence f dash x is greater than 0. So f is strictly increasing. Hence we can say f is strictly increasing okay, in pi to 2 pi. And we can take one more next interval, that is from 0 to 2 pi, since x belongs to 0 to 2 pi, and this is, since we can say from 0 to 2 pi, this is 0 to pi union pi to 2 pi, and from this we can say it is decreasing is increasing. So both we can say in this interval, we can say it is neither increasing and nor decreasing. Hence by 1 and 2 we can say neither increasing nor decreasing. Okay, so this way you understand this topic. I think it will be clear you. So student, in increasing and decreasing functions, you have understand these questions. So increasing and decreasing function is clear to you. You can do more questions from your book. Okay, in the next video I will tell you about more about maxima and minima, and you have to wait for same. Thank you for watching.